Right, I think we're up, and so welcome today. So this is a stream for the doing a just code, and today's topic is talking about the async functional programming, or basically talk about the async FP package that I have created and hello. It sounds okay. So so for this video, what we are going to do, I'll first go over what is the async FP is about and the underlying reason on why I create this package and how it is used. And then I will delve into the detail about the design, the actual use case. I'm using it in the Moctometer project, which I will go to talk about in the future. And right now is in the last stretch. The version 7 is really just around the corner. All the code is completed. I'm just going to do some testing and clean up before moving it from the beta to the actual 7.0 release. But that's for another video. So that's what we're going to do today. And without further ado, let's get started. All right. So first of all, what is this async FP, right? So it is a package, and inside there, my plan is to add multiple collection of functional programming utilities that's related to async programming. And for now, and for in the last couple of years, the async context is the only functionality is exposed. And the repository itself, if you're interested, you can go to github/url/asyncfp is right there. And it is set up as a mono repo, and the async FP is referencing the Url async context package. By the way, the reason I do this is back then it was before, when I first created it, was before the time of ESM, so you know how old this package is. So when I first created this, I was thinking about trying to create the same structure as the Lodash. So nowadays Lodash you have the main library, and then each of the individual functions are separate packages which you can put individually, right? So that keeps your package size small, your application size small. However, that is when back in the days in CommonJS, right, before ESM, before tree shaking. So that's why I created like that. But that's a side point. So I mentioned the key is this async context, right? So what kind of problem does it solve? So for that, let's first look at the README to make sure that we understand, right? The install part is just simple. Instead of importing, installing from the Url async context, you can install it through the async FP. That would probably the better way to do. It has a better name, and maybe in the future I would deprecate this and move the code in there. Right? So that's how you do that, how you install it, and then how to use it is a class, right? While because this stream is just code, so the flow is a lot more less structure and free form. So I'm just going to talk about whatever idea of things that come to mind, so that I can share those information in the most smooth manner. So when you talk about functional programming, right, a lot of times the first thing you think about is, there are three different paradigms, right? The structural paradigm, the functional paradigm, and the OO paradigm. And people think about them as very different paradigms, and they don't mix together, so to speak. So say, for example, when you talk about functional programming, a lot of people will think about language such as Haskell. Right? When you think about OO, you think about Java. Right? And then maybe even C++, because C++, quote unquote, is what started the OO movement, although I think it was actually Smalltalk do that. So when we talk about functional programming, you might find this using class is a bit surprising, right? But in fact, it is really not. And class, if you're interested in know more about that, class is really an encapsulation of behavior. Right, and then the benefit of OO is not about mimicking or modeling after some object. It's about dependency management, or about, as Uncle Bob said it, about polymorphism, right? About the ability to able to swap one behavior with another without affecting the code. So in my word, is about dependency, right? Injecting allow you to inject a different kind of behavior with the same interface. So there's no conflicts between functional and OO. Right? So over here, the reason it is a class is because it internally has some states. The information that it contains, the context it contains, is a state that is stored within, which you will get when you call the async.get. Right? And it will change along the way. So you can see down here, you can extend the context to get a new context, and then it will contain the context from the beginning all the way to end. Okay, so back to here, how to use it, right? You first you create the async context. Right? You can create it actually with no constructor param. But over here in the example, it showed that the few example that you can specify the initial context. And you can specify in multiple ways, just as an object, as a promise, as a function, or as an async function, right? The function returning a promise. So you're able to support all of them. And the way to use it is you first created this, or you create an empty one, and then down here you initialize it somewhere else. Then somewhere else down inside the code, you can call the context.get to get the resulting context that's stored within this async context class instance. Right. So the reason for doing that is that is separating the boundary. So for that, let me create a product over here. So it's the first time I'm using this tool. So give me a break if I was really slow. So when we talk about boundary, this is one of the things that Uncle Bob's teach, right? In the way that he described is there is a main boundary, and then there is the app boundary over here. So the thing about the boundary is that the dependency should only go one way. It should go from main to the application. So let's see how. Okay. So if I move it out and talk about do things like this. So another way to draw that is you typically have the app, right? Or have the main. Actually, I shouldn't really say the app. So have the main over here, and then you have some other higher level logic, and higher level logic call lower level logic, and then it call even lower level logic, right? So this is one way to describe the application structure, right? So these the main, the main boundary versus the app boundary is this, right? The main code will contain all of the concrete class. So remember, we talk about OO, right? So in OO, again, it's about the polymorphism, about the injecting the dependencies. It's about the dependency inversion principle. That the main code over here will provide the concrete classes that actually implement the interface that's needed by the code down here, this whole thing. Right, so down here, they optimally act up on some interface, and those interface are abstract. Right, it's the main that will pass those down there. So that this is the same drawing as this guy. It's just that this main was put to the top, and then this. Instead of a big tree, is just an abstract blob, right? That contain all the details, or not. Actually, I said it wrong. Not all the detail, all the actual logics. So that's the boundary. That's the main versus application boundary. So back to here. Back to here is that. The async context, you will create it in the main boundary, right? And then also you will extend it in the main boundary, but then you get the information, get the context inside the application, right? So because of there are certain cases that you would need to create your logic ahead of time, before those contexts or those dependencies are available. So you would need some kind of mechanism to get those things, later on any time. So one way with if you are not using the async FP in this async context class to handle that, what you would do is you're passing some object with some promise. Well, essentially, it's really that's what it does. It is passing some a promise which you can resolve and getting the result. It's just that this class formulates that construct and allow you to do a lot more things. Say, for example, well, as mentioned over here, you can initialize it in multiple ways. It can be async to begin with. It can be promise like this. And then you can also do the extend and add additional context to the instance. And when I said that, it's actually I'm lying a little bit, and I will get to that. And so that you can really extend and add more stuff to it, to your to the code that you are calling, right? Further down in the details, they need certain specific stuff, and you can extend the context and add those things into the system, into that context, so that they were able to get it. And you can do this whole thing asynchronously. So that's the power of this. And before you're using this, right, let's talk about why you need to use this, or the other way around, why or when you should not use this, or how do you avoid using it. Because while it is, in my opinion, is powerful, and I'm going to show you that when I show you the Multimeter, how I'm actually using it. Having async code deep inside your logic is not fun, right? It complicates the way your code communicate with each other, because now when you have some async call, all of the subsidiary code needs to be async. And then the way to communicate is you have to await for a promise, get the value, and then that code also need to be async, and then wait for things. And then when you say doing error handling, you have to do await and try catch and all those things, right? Of course, there are other things you can do, but typically, say if you do not have those other tools available to you, right, the code that you have will be become all asynchronous, right? So the best way to deal with this is have another boundary. So say over here, right? So let me try to draw the color again, draw this graph again. So you have the main, right? And then you're sending some context down there, right? Asynchronously. Say you some of those things are asynchronous in nature. Say, for example, your applications need some config, right? And that config can be either come from a file, which you can load synchronously, but maybe it also can come from a service, which would be asynchronous. You need to make the call, wait for it to respond, and then you can get the information, right? So it's asynchronous in nature. So for those cases, right, you have to do async, and there are cases that you don't want to wait for the whole thing to complete before you show. Say, for example, is a UI, right? You want to show some things first and then wait for the result and then update the result, right? And if you're doing React UI or really any web UI development, you know what I'm talking about. Of course, for those, there are other things that you can do, but over here, I'm straightly talking about some context, some dependencies, right? Although the example we'll talk about is the config, but it could be a lot more than config, right? So in Multimeter, there are things such as the plugins, right? The plugins are the actual code that you need to load. So you think about in the browser, you need to do the import module, right? To import the module from the server side to get the information, right? So those are really dependencies, right? In the most natural sense of what dependencies, right? Because they are code that you need to get in and use and execute, right? Instead of just configs of some kind of data, right? So back to here. So the main send those contacts inside to the application, and then there should be a line to say that, hey, I can get the contacts and then do the await over here to get all those things. So over here it may be some UI, right, saying that, oh, I know I need to wait for this, so let me show a loading screen and then wait for those things. And then when those things have arrived, then I further pass it down to the code down here. And the code in here do not need to be async anymore, because all of the async code is done, right, handled by this layer. So the complexity of dealing with async information, data, or dependencies are all handled over here, and then the rest you just do it normally, right? So that would simplify your code in quite significantly. Of course, although I know that the React recently talk about they will be supporting the async rendering. I hope that will be true, and I look forward to it. But even with that, that doesn't remove the benefit of having a good architecture, right? Design your code correctly, separating the concern correctly, so that the code is more reasonable. It's easier to reason and it's easier to maintain. So that's what that is. And so over here, what else I can talk about? So say over here, the initialize, this is saying that besides you can create it in the main context, in fact, you can also initialize it in another place. So you first create it in somewhere, and then you initialize it in another place, and then you use it in yet another place. So you can have it completely separated. So an analogy I can make is kind of like Redux, that you have the state, the actions, and the dispatch code. They are all separated, and you get the freedom of organizing them separately, and that is generally a good thing. So you can see that you can extend it using chaining. And I mentioned up here, when I talk about here, I lied a little bit, is because while I was saying that it extends the same context, in fact, it is actually creating a new context. So I can actually show you the code. Right, so this is the extend function, and you can see that it is actually creating a new contact and returning it. Right, so each time you create, so back over here, each time you do the extends is actually creating a new context. So you can see the example is that I am actually doing the initialize, doing all the extends, and then and then use that. Let's see. Actually, yeah, actually this is not right. Oh, I need to update the README, because what happened is currently the async context is in version 8, and when I was working on that, at one point I was trying to not doing this extending so that I can really keep the state internal. And there are cases that it turns out it doesn't work that well, right? So I switch back to this mechanism, and it is much better, much nicer, and also it works better in functional programming sense, right? So you extend it, you're basically creating a tree. You have the initial async context, and then you extend in some code. When you receive it, you extend it to get additional stuff, but you're getting a new thing. And then in another code, you also extend it, but instead extend it differently using different implementation, and you get a different thing, and then they all do separate things out there. So and then pass it to the functions that they depends on, and those code will use those two things, two contexts differently, because they are two different instances. If they were the same instance and just extend, right, keeping the state within the context, then when I was doing this, it's causing problem because, you know, when, especially during tests, because, you know, I test my code, right, they all the way make sure that it have a very high code coverage, and all the logic are well designed and well tested. So when I'm doing the testing, I find out that a lot of, if I'm doing this, some code will find that the code in, you know, in one path it set the value in one way, and then another code, because it's asynchronous, right? So the other code get executed in the middle, and it modified the context, so that the code down here, well, it was expecting it get the extended context from this extend function. It actually getting some information from this code, so it mess up the code. So it make, that's why mutation or mutated state basically is typically regard as a bad thing, right? Especially in functional programming. So that's why it is this. So yes, in fact, I might able to change this to just a function, right? Just function with some method associated with the function, you know, or just basically this is a function that return an object and do all that. But the benefit that I get from there is not that much. So, but by the way, I have something very similar inside the JustWeb, and the JustWeb, the create app function is actually very similar to the async context, but it is a function. And of course, there are some differences. It's do things, certain things differently. So that's why it is not using the async context directly over there. Originally, I was planning to, but then as I'm implementing code, I find out no, they are a little bit different. So yeah, so that's what the async context is. I hope I do a good job in describing what it is and how to use it. But anyway, before I get into the detail part, although yes, I already talked quite detail, I guess. Right, so over here, last thing I want to mention is the actual example. So just in time dependency loading. right? So these are the three use case that I share. Right? Is that you want to load the context only when you need it, or you will wait for it to be there. So that's what the just-in-time is about. And then for training, that means you can separate your code. Right, say over here, you do the load config and then load plugin. So they are both contribute to the context, but one is about the config, one is about the plugin. In fact, this code is actually comes straight from the Automata, which I will get to in a minute. And then here is about a dependency, configuration injection. So this means, right, so you create a context, and then you have some work that you try to wait for the context to be available, and so then you call it, right? You call it over here, and and this code will stuck over here and wait for this to happen until later on the application starts and the user, or when the whole application is ready. So say, for example, the config object, you make a call to the backend, the config finally come in, and then you call the configure function with that data. Then that will kickstart this work. This will resolve the promise over here, and the work will continue. So that is the another way, another use case that you can use the async context. So with that, let's take a quick break actually, and let me switch over to the Automata so you can actually see some code and how it is being used in live code. Okay. All right, let's back. I'm back here. So here is the Automata project. Right. Again, I will talk about this in the future. This is a huge thing for me. I created this a couple years ago. In the past, it's called Commando, and well, it's a behavior simulation system. Originally, before 7.0, it's called Commando, and I use that to write tests, and I'm able to write more than 150,000 tests out of it. So it is some very interesting thing to share, which I'll definitely get to later on. So here, right now, the topic is about async FP, or about the async context. So the way that this is done, this is used, is let me first describe how the Automata framework is designed, and so that you can see how it is being used. So in here, you can see that this is the index of the Automata. Excuse me, I keep coughing. So this is the index of Automata. And you see here, I initializing or creating the main key components that you are going to use in Automata. There's this commando, there's this motto, there is this zucchini, which has this scenario defined step and so on, right? And the way they are created is they have these functions and then passing in this context, right? And this context is this guy, which is a async context. So you can see over here, it first it is asynchronous. The reason I think nowadays actually I don't need to be async anymore. I can simplify because a while back this was asynchronous. So you can see that I have the freedom, right? I have the freedom to do async or not async. It doesn't really matter, and the async context will handle it for me. So it have this IO, right? You can see a clear dependency injection working over here, right? The IO is passed from the top, right? The IO over here, this is the IO that implement in the Node.js, right? So what it does is it can get config, it can load plugins, and it can save the record and load records. So in Moctometer, I mentioned it is a behavior simulation system. So what it will do is it simulate the behavior. I end up talking about what it is, but very quickly, it capture the behavior of some code and then create a spec record and then save it in your file system in your repository. And then the next time you run it, it will able to get that and replay the whole thing. Right, so the IO will handle that. And over here, again, this is for the Node.js side, but it can also, the Moctometer can also run on the browser. Right, although right now I haven't really finished that part yet because I was focusing on the Node.js stuff. But you can see inside the project, I have the I have some service, I have a IO remote, and which this is the IO on the browser side, which will talk to the server in the service to get the same data. So you can see that is the IO is a polymorphism, right? It sends a different IO depends on what kind of environment or platform that you are running the Moctometer with. The same thing for the log, although it's only one, although it could have different settings, and then also this configuration, but that's a very small thing. So it creates this async context, and then it send it to one of these three functions. So in this video, I'm just going to use one of them as an example. So inside this create Mocto function, right? You can see the first thing it does is extends the context with three things. As I mentioned, the config, the plugin, the example you saw in the async FP, it comes straight from here. So it is a asynchronous process to load the config, because what this code will do is it goes in to get the IO, right? The IO class or the IO instance provide over here inside the context. In there, it will use that to load the config. The same thing for the plugin. It will load the plugin and then actually inject it, add it into the system, and then also provide some additional context that will be available for the subsequent code to use. Right. So one of the example on that is over here. There is this tear down function. So this guy will get the code and get the time tracker to make sure that they are all terminated when you tear down your test. Right, so that's that. And then this context, you can see, is passed down to this 4 locations. Right, they are the same code. The only difference is what kind of mode is executed in, and for the context of this video, you don't have to really care about what it is. So we can just go in here, and down here you can see that it's further extend the context to add in more things, right? And over here, one thing that is interesting is that you can see that this spec function, it takes in some arguments. The function is typed outside, right? So over here is just a any array. And from there, it tries to extract the extract the arguments of this spec function and makes it make sense, right? So it have this spec name, have this option, and have this end handler. And that's where it start injecting this down also inside to the context, because the create spec object will use it, will use all this information, right? So it get additional information from this call, right? So we are already 1 level down, and you can also see that depends on how this code is being called, right? So this over here, right? So the way to use this code is the mocto. This function can be called directly like this, or it can use this 3 function: the live, the save, and the simulate, right? So it's the same, but by just passing this in, the async context in, and extends it inside the code, now I'm spreading the context to 3 different instances, although they start with the same code, right? The same instance. So they start changing with different input, right? Depends on when and how it is being called. And then also here is get the effective spec mode context, which based on the mode input that's specified over here, right? So this get effective spec mode come from this, which come from here. So you can see that it start breaking it down and separating them out, and then inside here it further call this spec functions and do all this, and at the end here is where it is using the code, right? So here it get this mode, for example. So let's move that to the right hand side so you can see. So this mode is actually come from this code. So now I'm actually passing that down and get that information from here, and all of them asynchronously, right? I don't have, of course, you know, when it gets here, some of it, or in fact most of the things when they get to this level are synchronous. It doesn't need to be asynchronous, but the things that they depends on, right, were asynchronous, right? So back over here, like say they're loading the config and loading the plugin. Of course, the same thing about when they go further down over here, when create a spec, right? It load the spec record or save the spec record. Those are all asynchronous. So by using the same construct, I'm able to pass it in one place and access it in one place. And I'm able to do all this distribution, separating the instance to all this different code, and so it is easy to get. So that's how it is being used in the Moctometer. So I want you to think back a little bit. If I do not have this, how would you write this code, right? You would need to pass this in, And then the information like this, the init time tracker, this spec name options, these things, they all somehow need to pass it into this code, and then to this code, and then to this code, right? So if you think about OO, right, they probably are different classes and different instances, and passing them in all the way and do all that, and some of it will be async, some of it will not. You can see the code can get quite complex, and either your function, the arguments will be quite long, or it is you have to create the type and mix them all together, which, to be honest, is not too bad of a thing to do. However, using this async context, I'm able to normalize it and have one consistent API that I can use to get all of them together, passing them down, and then the code down here, all I need to do is, I know I would have this code, this context, this information, I just grab it out and use it, and that's it. So that makes the code a lot easier to handle, at least in my opinion. So that's how the async context is being used in Mautomator. And with that, that's it for this stream. And I hope you find this interesting, and I hope you learned something. And if you have any question about the async FP, or about the functional programming in general, or anything I said is wrong or something funky, or you have some idea or opinion, feel free to add your comments down below. And also, where is my overlay? So you can see over here there is a Discord server. So feel free to join too, and over there you can ask me any question. Right. So that's it for this video, and yeah, hope you enjoyed it and hope you learned something, and we'll see you next time. Bye bye.